Thank you so much. And I feel like I'm going to look really silly with this in my face the whole time, but I will do anything for the live stream people. Hello. Thank you everyone for being here today, and I'm excited to talk to you about machine learning from a product manager's perspective. And so let me tell you a little bit about me before we dive into the topic today. So number one, by day I work at Google, and I am a product manager in the hardware business. So for those of you who know about Google, hardware just became a thing at Google formally last year. And so I work on products that are at the intersection of hardware, software, and artificial intelligence, and machine learning is one flavor of artificial intelligence. In particular, I work on accessories for the home. I don't work on the home device, but certainly accessories that may go with that device or may go with other devices in the home. Can't really tell you what I'm working on. What I also do a lot at Google is PM interviewing and also coaching of people. Google has rolled out a brand new coaching program where you can have a session with an interviewer before you even go through the phone screen. And so you can practice and get feedback because they want people to do well, and they understand that people get nervous about interviewing at Google and other places. So I do that. The third thing I do at Google is I facilitate their innovation labs for all Nooglers. I'm there's a team of folks who lead their creative skills for innovation program. And so all Nooglers go through this lab as part of their orientation, which I thought was really cool. And then we also facilitate for nonprofits and entrepreneurs and other partners we work with. By night, I also am an entrepreneur. I have a startup called NLS, and it's really about digital skills development for professionals and for businesses, predominantly industrial businesses that are trying to make that transition from, say, manufacturing into being a digital company. I went through this at GE, and so there's a lot of challenges with that. For professionals, what I do, because I do so much coaching, I actually do have an offering where I help people be the right candidate for their ideal job in the tech industry. I have no idea why this rebooted. Yeah, not sure.
Maybe it's just a keyboard?
Or maybe, I'm not sure if this went to sleep.
Good. It's good.
Hopefully I can get it not to go to sleep. And then, and so I'm a PM by nature. I've been a PM so long, even before I was officially a PM, that I'm actually happy they have a role called PM, because I've been doing this a long time, and I'm one of those PMs who have actually been in all three pillars of PM. I've been a UX strategist and designer and researcher. I've been a software developer. My background's in computer science, and I've been on the business side as well as an entrepreneur and in a PM role. So I'm passionate about launching products that make a difference in people's lives for the better, basically. All right, 2 truths and 1 lie. So this is going to be kind of interactive. And you don't know much about me, but here's 2 truths and 1 lie. And maybe you can take a look at this and let me know which one you think is a lie. So hopefully you can read that. It's about my PM experience, my life's journey, and revolving restaurants. Any takers?
Life journey.
Life journey? Any other thoughts? No, just shout it out, Pop.
PM experience.
PM experience. Okay. Anyone for the revolving restaurants? Yeah, it's a thing. Okay, so whoever said life journey, that's true. My life journey has definitely been an interesting one where I was, grew up abandoned by both parents by age 7, grew up in foster homes. Definitely not someone you would expect to be here today. But fortunately, I discovered computers in the 5th grade, and I was like, I don't know what this is, but I love it. And so I went on to study computer science, do a PhD at Berkeley in computer science, was the first African-American woman to do that. And I've never looked back. What I've learned in this journey, though, is that technology can make such a difference in people's lives for the better, and that's why I'm passionate about product management. Okay, let's get on with it, right? So let's start by distinguishing all these different terms. You've probably heard, of course, you've heard machine learning, you may have heard deep learning, artificial intelligence, etc. What does all that mean? And then we'll go through what is a machine learning process? What does that look like? And then finally, if there's time, if you have a lot of questions, by the way, feel free to ask a question anytime. You don't have to wait till the end, because this can be complicated material, so just, and there's no such thing as a silly question, right? So just ask it. And then if there's time, I'd like to go through how do you actually land a job as a PM with a role that's looking for someone who understands machine learning. And I'd like to actually do a mock interview question. So think about if you want to volunteer. I'm looking for people who know nothing about machine learning. And the hope is by the time you get through, if you can do a mock interview to make me think that you actually know something about machine learning, then I succeeded in my talk. If you look stupid, then I just bombed this talk, right? So I take responsibility for that. So you might want to pay attention. Okay, let's take a WAG. Anybody know what a WAG is? It's a wild ass guess. Say it. So there's terms on the left: analytics, artificial intelligence, computer science, data science, deep learning, and machine learning. You probably don't know what any of those are. Therefore, you have 6 definitions on the right. So your task is to just take a wild ass guess about which number goes with which letter. So just spend a few minutes on it. Let's give people time to think about it. See what you think.
4C.
4 is C. Data science is C. Any other thoughts?
2E.
2 is E. Artificial intelligence is the theory, experiments, and engineering to inform computer design use. 5 is A. Deep learning. Okay.
F is 3.
F is 3. Okay. 1 is B. I'll take one more and then I'll just stop torturing you.
3 is B.
3 is B?
Yes.
Okay. One more. This is good. Any other brave soul? Just one more. 1 is 3. 1 is D? 1 is D. Okay, in the back, yes.
C is 6.
C is 6. Okay, let's just put the end to this one, right? we could just go on and on and on and on. Okay, so here's what they are. So computer science is a field, just like electrical engineering, just like data science, which is not up here yet because it's a separate field. Computer science is a field that deals with the theory and experiments and the engineering to inform computer use design, right? A subfield of computer science is artificial intelligence, which is how do you make computers mimic the human mind? That's what artificial intelligence is about. That's what it means to be artificial. And then machine learning, which we are focused on today, is yet a subfield, subdiscipline of artificial intelligence where really what you're trying to do is get a computer to learn without telling it exactly how to learn. So in other words, how can you put something into some algorithm, it learns something, but you didn't tell it exactly how to do it. You didn't program it yourself. You didn't hand code the instructions. So has anybody ever did any programming, coding at all? Okay, so when you code, what do? You give the computer a sequence of instructions what to do. So machine learning is how do you do that without giving the computer explicit instructions of what to do, okay? To learn, for one particular purpose, learning, okay? And then deep learning is one way, one algorithm, or a class of algorithms, really, for how do you learn from data. And it's not the only one. There is a lot of algorithms. We'll talk about that today. But the idea is machine learning has a whole suite of algorithms. Deep learning is one type of algorithm. Yes?
So is machine learning a subset of artificial intelligence?
So the question is machine learning a subset of artificial intelligence? Exactly. Yes, that's why it's in here.
Can you give us an example of AI that's not ML?
Can you give me an example of AI that's not, if I seem retarded because I'm repeating this, it's because I was told I have to repeat the questions. So I'm not trying to, I just want you to know what's going on here. Okay, so the question is, give me an example of artificial intelligence that's not machine learning. Natural language processing, speech, is another form of artificial intelligence, right? Okay. So machine learning is all about how do you teach the computer to learn, whereas natural language processing is about how do you teach the computer to speak or even to write to some degree. Okay, and then data science is yet another discipline. It overlaps a lot with computer science, but it involves way more than computer science, right? It involves math, it involves statistics, and other things. So just because you're a data scientist doesn't mean you're a computer scientist. And because you're a computer scientist doesn't mean you're a data scientist. I just happen to be both. But there's overlap. And then analytics, which is something you hear people talk about a lot. And what is an analytic? Well, that's similar to machine learning. It is the discovery of meanings, patterns in the data. It can happen manually, meaning you just stare at data and somehow it reveals to you something like people who wear green dresses wear green jewelry. Right? You discovered that. That's useful. You can do something with that. Like every time somebody shops with a green dress, push green products at them. Accessories, right? Or if you discovered they like purple with their green, then you can push some purple accessories with the green dresses or outfits. Okay, but it can also be, it can be automated or manual, right? But it's distinct. Now you may use some machine learning algorithms to find patterns, right? But it's a little bit different. Any questions about this? I know, thank you so much for taking a wag with me. Do you feel like it really was a wild ass guess? Your thought? Okay. Okay, if you're sensitive to curse words, I apologize. I'm told that people who curse are quite intelligent. No, I didn't make this up. I promise. I've seen the study. Yes.
No, I actually do agree with that. So question for you. Do you mind just running through a very kind of quick example of maybe a data insight that you found? You can kind of teach us the steps and where everything is. Like, give an example like that green dress, green accessories.
I'm going to take you through a concrete example. This is just my warm up. There's more, like the infomercial. But wait, there's more. Okay. So now we get to what you were just asking, is understanding the machine learning process, okay? Any other questions before I move on to the next topic? Is there a way to post for questions in the live stream event? Is there like a chat where people can put their questions in? No? Okay. Now, machine learning. Let's look at it from the top. If machine learning was a physical object, something you can hold in your hand or maybe throw on the floor and look at, it would probably look like a T. And I made that up. But let's just say it looks like a T, if it had a shape. Why is that? So let's talk about it from top level. Number one, you have to ask good questions. Now I'm going to go through each one of these and tell you what they mean, so just bear with me. You got to ask good questions. You have to know what you want to know before you even start the process. Believe it or not, the second thing you need to know is what are the target algorithms you're going to use as part of the machine learning process? Why do you need to know that? Well, because the algorithms dictate the type of data that you need to collect, or how you need to prepare it to go into the algorithm. Certain algorithms only deal with certain types of data. And also, you need to know what type of answer you're going to get. So the algorithm determines what type of output you get. So you need to at least know something about, I'm targeting this particular algorithm before you even collect any data. Then you start following a structured process here. And that process is, you're going to use good data. I'll talk about what that means. But the thing about machine learning, if you put bad data into it, what do you think is going to come out?
Bad answers.
Bad answers, right? So you got to do good data. Then you actually apply the best algorithms. It may be more than one algorithm. So sometimes, depending on your question or questions, you may have to use more than one algorithm. You may have to build more than one model. And you may have to string them together in some way where they collectively come together to give you an answer, right? Through fusion or something like that, where you get the answer from multiple models, see what the majority answer is, for instance, and then you make a decision about what the answer is. So you got to use the right best algorithms, and these algorithms require you to tune parameters, change settings. It's like you're spending a lot of time trying to make the algorithm give you the best result. Yes?
Models and algorithms, do you need mathematicians to create them, or do you use things that are already available that have been created before?
Yeah, so the question is, models or algorithms? So models are the outputs of the algorithms. The algorithms are take the data and give you a model. And the question is, do you have to hire some highfalutin mathematician? No, you didn't say that, but this pretend you said that. Do you have to hire some whiz-bang rocket scientist to build the algorithm, or do you use things that are available? Well, that's the beauty. You use things that are available. Now, if your data, your question, does not have any algorithm that exists in this wide space of algorithms that are available, then you need to go hire some highfalutin person to create an algorithm for you to build that model. And that happens all the time. Models get better, algorithms get better all the time. We keep refining them. So that's the quick answer, yes?
Is there a large data source of algorithms that you can, like open source algorithms that you can access?
Yes,
From
there
like
is.
Google or some other source?
Yes, there is, and I actually
That
have
was a
that.
setup for you.
I anticipated all of this. Let me, one thing I didn't tell you. I actually used to be a professor, and I've taught, I think my machine is going to sleep and I can't. Does anybody know how to make this thing stop going to sleep? It could be a Google thing, I don't know. Because I turned off the screensaver. So I guess what this is telling me is we have to keep this moving. But I have been a professor and taught, so that's why you don't get to just sit back. I'll bring you in. But yes, there is, I do sort of give you some tips for how to get started and point you to a great resource for that. There's sample data, there's sample courses, there's a lot of stuff freely available, basically. Any other questions? Yes.
Can you elaborate a little bit on what you said about algorithms?
Yes, I
and then
will.
Models?
I
You
will.
said that the models is an output of algorithms?
I will give you concrete examples, okay?
Thanks.
You guys are so eager. I love this. I'm getting to it. Sorry. Anything else? Any other questions? Yes, go ahead. You had your hand up. Unless you had it for somebody else.
It does that sometimes.
Okay. You let me know. Do you want to? Would you like to ask a question?
Yes.
Okay.
So in traditional software development, it's common to think in terms of inputs and outputs. Can you string different algorithms together? If I heard you correctly, can the output of one algorithm lead to the input of another, and so on and so forth?
Brilliant question. So the question is, can you string algorithms together into a pipeline or a workflow so that inputs from one algorithm becomes, you put something in the first algorithm, the output from the algorithm goes as input? Absolutely. That happens all the time. Like, think about Google search or something like that. That's exactly what it is. It's a pipeline of different algorithms that are applied to the data. Okay, then you deploy the model in some way. You got to put it in your code or wherever you're planning to use it. And then you rinse and you repeat. And this is important. When you're using machine learning, you don't just build the model once and you go away and you never update it. You usually, you learn something new data is available, you keep going back through this process to refresh the model, to improve the model. Okay, that's the process, and I'm going into more detail on each one of those. So let's start with the questions. Here's 3 examples of products I've worked on. One is website design. If I am a designer and I create a website, how do I know if this is a good design? Yeah, it kind of looks pretty, but is it really a good design? Is there an objective way to measure this? And if I know it's not a good design, or if it is a good, tell me why. Why does this work? And if it doesn't work, how do I improve it? This is my PhD dissertation. So I can talk about this one in a lot of detail, go under the hood. So this is the example we'll use. The other 2 I can't talk about, right? Because nobody, look, the models, the algorithms are these companies' secret sauce. So they don't want anyone to know their secret sauce, right? You probably have a recipe you don't want anyone to get a hold of, right? It's the same thing here. I worked at GE on, I was the PM for software to control power plants. Very different than Google, right? But it's exciting. I used to love putting on my boots and my hard hat and going to these power plants. But we have these gas turbines that generate power. So how do I know if my equipment, my gas turbine, the thing I've paid millions of dollars for, is operating optimally? How do I know that? Well, there's algorithms for that, to answer that question. And essentially, the turbines has hundreds and thousands of sensors, tons of data sent every millisecond, tons of data. And it essentially creates, you have a model that is essentially a digital twin. You've probably heard people talk about that before. But if not, a digital twin is a digital copy of the physical device that tries to mimic every aspect of its behavior, from the thermodynamics to the wear and tear, all of it. And so you use that to be able to say or see when it's starting to go off of what you expect it to do or perform, and to bring it back, and why. Yes, question?
How do you define optimal in this case? I mean, because you could have a various series of optimal. I mean, optimization could basically mean it could be done based on the demand model of the generation and pricing, or input. I mean, there's so many different ways of deciding optimal. So how do you decide optimal? And technically, you can make a whole bunch of algorithms and decide based on multiplier effect what needs to be at what time. So I mean, in this case, if you don't mind sharing that.
Sure. The question was, how do you define optimal? Because there's a lot of different ways to do that. And what they did, and this is public record, public product, they have different definitions for optimal. It could be based on other gas turbines similar to you, meaning the GE fleet, others in your fleet, others in the region, others with specific configuration, or if you had an updated one with all the latest, this is what optimal looks like. So in this case, they have targets. You choose to target, and it'll tell you if you're operating in alignment with that target.
One thing in common between all of them is basically it can be custom for each individual user. I mean, technically speaking, it doesn't have to be what is a good design. Good design could be different for each person. Same thing with the operating of the turbine and what to show initially. So sure, yes, but they don't do that, right? To some degree.
So good design, in this case, it was based on the websites that had been evaluated by the Webby Awards judges in the early stage that had everything from the very good to the very poor. And so you learn, when you want to answer this question, you have to learn the answer to it, right? By collecting data. Same thing here. the different models. You learn what optimal looks like by mining data to come up with analytics. The third one, this is Google search. When you go there, how many people remember when Google search just had an empty box and that was it on mobile, right? But now, the new and improved version, you have a couple categories. I'm willing to bet if you're in different parts of the world, these categories are different. And then when you click on one of these categories like entertainment, it shows you the latest. What you can see is this latest was from 12 hours ago. But yet, why is it that shows up at the top? There's surely stuff that was created like 5 minutes ago, but this 12-hour one is at the top. So this is part of the machine learning to figure out what to show initially and what to show first. Yes?
One of the questions about, for example, what to show initially, I'm surprised that, is this an example of a question, like a good question, or is it something like just to set the stage for something? Because I would think that the question to have for what to show initially would be like, what should I show to get a click-through rate of a certain percentage for a subset of customers within like a certain amount of time?
That's really good. So the question is, are these the actual questions that these companies are using, or is this an example? Both, right? I can't tell you what question Google is answering. I told you what question GE is answering, and I told you what question I was answering, right? All right. Any other questions? Yes, all in the back, the green.
Yeah. Could you tell a little bit about how the web design evaluation part overlaps with user experience research? How does like the machine learning design evaluation overlap?
Okay, so the question is, can you elaborate a little bit about how web design, machine learning overlaps with user experience? So I will show you more, but let me tell you quickly. How did I come up with how to evaluate what was good? Well, I went to the literature. I went to the design guidelines. You know, certain guidelines would say, don't use more than 4 colors on the page. And I said, okay, how do I measure how many colors are being used? Other ones said, your paragraph shouldn't have more than this number of words. So how do I measure how many words are on the page? So you'll see when I show you example metrics, they are definitely tied to UX. And then once I built the models, because what happens is a lot of time the guidelines conflict each other. One says do X, the other one says do something completely different. Once you build a model and you have empirical evidence, then you can go back and say, well, based on my model, you should do X, which is actually what I've done. I have publications around that. Yes?
Just to help tie the previous slide to the more concrete examples, there are 3 different categories and 3 different types of data. So if data is the input and into an algorithm and the model is the output, does that mean that the model has to be tied to where the data is stored, or can if the model is an output, can the model live in any container, so whether it's a laptop or a power plant or a phone?
Yeah, that's it. So he's asking, does the model and the data have to live in the same place? No. Actually, I'll show you more in the next slide. Let me advance. Well, I'm sorry, I thought it was, but in the one after this one, I will show you the process in more detail, and then it'll be clear to you that these are 2 separate phases of the machine learning process. The model building, or the learning part, and then the actual predicting. And once you deploy, you run your model wherever it is. You still have to figure out how to get the data in, but no, they don't have to live in the same place. Okay? You would hope so, because your model would run faster. But you can do whatever you like. Okay, still talking about questions. And I know I'm moving a little slow, I'm answering questions. This is your time, right? Remember, you gotta have this mock interview. So if I don't do well here, you're gonna suck in this interview, and we can't have that, because then it makes me look bad. So one other thing I want you to know is, remember I said you have to ask good questions. Every question has a certain value attached to them, a value to the company, a value to a customer, etc. So if you start at the very bottom, and you're really just trying to monitor things, and you want to know what happened. You know, that something happened. That's very low value. But if you progress up a little bit to get to trying to diagnose why it happened, that's more valuable because you can give people information about that they can act on. You know, so you say X happened, like I noticed that the click-through rate for this query is very low, right? That's a what? Maybe you had a trigger like, I'm not saying Google has a trigger like that, but let's just say they did. You know, if they set up a trigger, I want to know when I'm not helping people with searches. One thing they could do is say, I have a rule, and it's a simple one. Let me know searches where I can build an algorithm that describes all the types of failures on searches. And it can let me know when there was a failure. It doesn't tell me why, but then if it told me why, I can do something about it, right? But then let's just say it can actually predict that this particular thing is going to lead to failure. That's way more valuable, right? It could tell me when. It could tell me what will happen, right? But then what if it could optimize things? What if it could tell me stuff even before it happened? And tell me, or do what-if scenarios. Like run through all the different types of queries. Tell me which ones are likely to fail. Why? Then I can do something about it in advance, right? So that's most valuable. Why is there a different value? Because in these two levels, it's hindsight. It's in the past. You can't do anything about it. In the middle, predict, that's more insight, just in the moment. You could take action on it, but foresight is in the future. You know, the optimize is in the future. You can definitely do something about it. That's how you prevent failures of power plants. Like for instance, today, I had a couple guests that were supposed to come. BART had a power outage, so they couldn't get from Fremont to here. What if BART had some algorithm, machine learning running that could tell them in advance, hey, on June 1st at 3-something p.m., you're going to have a power outage. Do something now. And it lets you know like last month. That failure probably wouldn't have happened and my peoples would be here. That's a failure to use machine learning. Okay, and the reason is, at the bottom, you're just dealing with information. At the top, you're dealing with optimization. Questions? Yes. Any questions? No questions? Okay. Yes.
Quick question. If you only deal with the hindsight information, is that still considered machine learning, or is that just like a precursor to machine learning?
No, all of this is machine learning. But this is the questions you're answering with your question. What I'm saying is, depending on what question you ask, you're going to build machine learning models that are more or less valuable. If you ask more what if, how to, now it's harder to build models for that, but you're going to get way more value out of it. So it's all machine learning. These are just the questions.
So are the bottom two a precursor to the top two?
Not necessarily.
Can you explain why?
Because you're assuming I have to build a model that does every level. Not necessarily, right? I can do the optimize, and it lets me know maybe every month what might likely go wrong. Is it monitoring the system? Maybe, but does it tell me everything? Maybe it's not even set up to trigger when there's a problem. Maybe it's just set up to only tell me when there's a likelihood of a problem. So you don't have to do this. Now, you can build a model to tell you all four. Not one model, though. It's going to be different models, and each one of these could be several models, right? Because each question requires different data. Yes?
So will you require different data sets in order to answer these different questions? And are some of these questions harder to answer because of the kind of data that's available or not available?
Yes, this is true. Very good. So the question is, will these different types of model require different data or be harder to answer, right? And that's true. Which one do you think takes the most data? The top, right? Which one do you think takes the most sophisticated model? the top, right? This one, monitor, you can just do simple decision trees. If this, then that. If the temperature goes below this, there's a problem. And I just detect when the temperature drops. But the decision tree rules could come from mining the data with an algorithm to figure out those types of rules. And it's really just thresholds. This one is probably like, you know, very complex things that happen over time. It's not like one instance the temperature dropped. It's like over time, gradually your heat has been going up and your output has been going down, and there's 50 million other variables with the weather, and when the weather is like this, it does that, and you know what I mean? So it could be extremely complicated. And time-based. You got to monitor over time, not like in an instant. That's a more complicated model. But it gives you the most value. So what usually happens is, like a GE, right? Because this one is, the biggest thing you don't want to happen is have a power plant outage, an unplanned outage, right? Your customers are mad because they have no power, and you lose money, lots of it. Power plant can be down for a couple minutes and lose millions, right? So you don't want that to happen. So you may start here. Let me figure out, like I have data from failures, and I want to learn rules for when these failures happened. Then I can monitor. Then I may graduate into trying to diagnose why it happened. Then I may graduate into trying to predict a failure. Then I may graduate. So sometimes you may have to graduate upwards, right? Because you may not have all the data to start at the top, and you might not have the expertise, right? You don't know. So you got to build that expertise, and you see what's happening with the models over time. Yes?
So when you train a model, you're basically using a hindsight regime, and then at some point when you gain insight, that becomes a hindsight because you're always training on the hindsight.
So the question is, when you train a model, are you doing hindsight data all the time? No. There's different algorithms. There's algorithms where they can learn in the moment. Like, you think about the AlphaGo that just won the competition again. It's not based on hindsight. And I will tell you all about those algorithms. We'll get to that. Anything else? Any other questions? Everybody okay? Everybody's good? Nobody's sleep? Anybody bored with me yet? No. Oh, okay. If you're bored, just you know what? You can raise your hand and say, I am so bored with you. Would you please do something to excite me?
You should be learning that as we go along.
What?
That we're bored.
Okay. Oh, learn. Oh, that was good. That was good. I didn't even catch it. Okay. We're getting there. Look, I'm taking you slowly because I really want you to understand this for this interview. Okay, so here, phase one, there's a learning phase. You start with your questions. Remember, you need to know which algorithms you're targeting. So you need to understand the algorithms before you even understand the data. Then you do your data collection. That data is usually dirty. So you can't use dirty data, so you got to clean it up. Believe it or not, just dealing with the data will take you 80 to 95% of your time. And then actually building the models and evaluating the model, it's so quick. You can spend weeks, months collecting data. And then you throw it into the algorithm, and 5 minutes later, you have a model. How depressing is that? I want the model, and I got to go through all this just to get it. It's mind-boggling, right? But yeah, it could take 5 to 20% of your time, just building the model. And then you deploy it. Meaning, you put it somewhere where in phase 2, you're doing the predicting. You're giving it new data. You have to compute the same features that you did to build the model here so that you're running the same features, same type of data, same fields through the models that you've deployed. And then you get a prediction or an answer or an outcome, which is what you really wanted all along. And you may do some adaptation. So if it's an optimization model, then what are you going to do when you've predicted that something is likely to happen? Do you adapt Do you do feedback to the system to say change in this way? So that could be a part of your process too. I promise, I'm working my, see, you can see I started with questions. I'm going through each one of these, okay? Just so you know where we're going. Yes?
Is algorithms models now? Based on
The algorithms are here.
Yes, but
They create a model which is deployed. You use the algorithms to create the model. The model is what you put data into and you get a response from. It'll make more sense, I promise. Yes?
Are the target algorithms like your Legos and the model, you just piece them together and it's a model? A couple of different algorithms, or you use a couple of different algorithms to piece together a model? Is that what?
Okay, so that's the same question I was asked earlier, but a very interesting way. So it was a question of, is your models like Lego blocks that you string together? Yes, you could have a model that is a collection of models strung together in a pipeline.
Or algorithms.
You could use multiple algorithms to build different models, and then you bring them together. It depends on the complexity of your question. All right, so you can string them together, and you can also run them in parallel, look at the output, and fuse it into a single answer. Through some, you can have an algorithm for how you fuse the answers from different models together. It gets really complicated, and I saw a lot of hands go up. Yes? Eric?
So would it make more sense to say like your data is essentially your Lego block, and the algorithm that you're using is the tool to assemble those Lego blocks to construct the model, which is the overall structure that you've made with the Lego blocks?
I have no idea how we've gotten into Legos. I love Legos. No issues with Legos, but I'm not sure that that's helping us. Right? Because Lego doesn't do anything. If there was a correct analogy for a Lego thing, maybe it would be a model. And you're piecing them together to create an output. Right? I know there was another question. Yes. Please don't ask me about Lego.
Yes. So you said that once we deploy the model, we get answers and a prediction. So we know that we predicted it to be, let's say, true. It turned out to be false. Using that data, do we put it into other algorithms, or how do we use that data to better our model?
You're talking about the adaptation.
Yeah.
Yeah. You decide what you want to do. You don't have to do anything. You can just get the information and sit on it. But usually you decide you're going to do something about it. And that's what the adaptation is. It depends on you. What do you want to do? So you have the question, but why do you have the question? In other words, if you have this answer, what are you going to do with it? So that's the question underneath the question. Yes?
Does the first part, the data and the algorithm, does those two kind of phase, are not they going together? Because in a certain way, your algorithm will kind of define the way you clean your data now.
Well, that's why I said you need to know here, when you're asking your question, which algorithm are you targeting? You're not using it here. You just need to identify the algorithm because it's going to affect your data cleaning, and you have to make sure that data can be fed into the model building. That's why I said that. By the way, nobody tells you that. I'm the first to tell you that. You've heard it from me. It's all about the algorithms.
For the second phase, are you just putting in new data
Yes.
that you have never tested?
Yes, exactly. So you have grasped the gist of it. You're building a model. Why? So you can put new data in there. You can use it ongoingly. So that's really interesting because you need to be able to generalize this model to all data.
So you're keeping the old data, right? And then you're...
Well, once you do the model, you don't need the data. You got these two separate processes. I got my model. Forget this data. I got me some new data. I'm rocking and rolling. Later, I might have to collect completely different data and start back through here again to build me a bigger and better model. right? That's kind of how it works.
So are you saying that it just keeps looping around?
These two, the only connection between these is whatever model you deployed here is the same thing. This is your deployed model. Now you're in a predicting phase. You don't, depending on your method, there are some methods where these two are tightly woven. You're constantly learning and predicting and adjusting the model based on what you learn.
Right, supervised machine learning.
No, that's unsupervised. No, actually it's reinforcement. We'll talk about that actually, right? I'll distinguish those two for you. Yes, questions, yes.
So based on what you just said, it's like if there's like some tweak at all to the algorithms, you might have to scratch the whole data collection phase and restart, right?
If you didn't collect the data right and you can't get the right output, so what you'll find is you may have target algorithms, plural. Why? Because you don't know if they're going to work on your data. Until you collect the data, you clean the data, you run it through the model and see what happens. The first time, it's usually not going to be pretty. So you got to change parameters for the algorithm to see if you can get a better result. If that doesn't work, then you got to try a different algorithm. That doesn't work, then maybe you try to do things and combine them. Maybe you need multiple algorithms to give you the answer, right? So it's like a dance you have to do to try to figure this out. Yes, sorry, here.
I'm going to pull on her thread a bit, because I think the term, and at least in my mind, maybe I'm just being silly, is there's this notion of training data. So let's say I wanted to build a model to help me detect images of bananas. And because of my constraints of my company, I can only collect 10 images of bananas. That's all I can do in the time window that I have to collect data.
Yep.
So maybe I take 8 photos of those bananas, I put 2 aside, I feed those 8 images into my algorithm, and then I have a model that I'm feeling good will be pretty good at detecting bananas. And then now, those trained models, I put the 2 unseen images of bananas in and see if I can predict if it's a banana or not. Is that?
Thank you very much for that. You've just explained supervised learning to some degree. We'll talk about that too. But yes, you are on to it. This is great. Did you know anything about data machine learning before you came?
No.
You just learned it.
Data and...
So you're jumping to the next logical. Very good. I must be doing well. Because you learned something. Yes, I will talk about that when I get into the algorithm piece of it. Yeah, but you're correct. Questions? Yes, right here.
So is the idea that once you got through all those phases of the data cleaning, building the model, and then as long as your data classification or categorization doesn't change, then you can keep just using that model and continuously learning? That any time your data classification changes or any of the questions change, you have to retrain the model. Is that
yeah, that's very good. So the question is, as long as I'm so astute observation. Whatever you do here to your data, you have to do here for your new data. The new data has to come in the same exact format as what you built the model on. Same field, same cleaning process, all of that, to feed it into here. And then you run it through your models. If nothing changes and you never want to get better, you could just run that same model for the rest of your life or the life of the device or whatever you do, right? But if you want to get better, you may discover there's even more, maybe you have more capability to collect more data, which means, okay, I can collect more data than I did the last time, meaning more fields. And, you know, more different types of failures, whatever your data may be, then that will trigger, I need to build a better model. Yes?
If you put the data collection, data cleaning into an AI model, machine learning model, deep learning, whatever piece of that is, maybe your data coming in will change, and you want to have that be cycled so that it can continue to get smarter as the data changes, and then you have another model to be able to analyze that data, and then the things you're looking for change. Do you see that being like a big loop of this? Like, how do you continue to teach both of those pieces of AI?
Very good. You guys are just awesome, right? So what she's picked up on is this itself is an algorithm. that may be a precursor here. So really, your deployed model could be an algorithm for cleaning the data, and then you apply the machine learning. And there are some algorithms, machine learning, around this process too. There's filters around this process. What I can tell you is they don't always do a good job. A lot of this is manual. Even though we're in an automated age, a lot of it is manual. Okay, yes?
So it's a manual process. How do you know, I guess, how do you distinguish what to keep from what to take out and when you're cleaning it?
Yeah, okay, I'll tell you that. Basically, you're saying, how do I clean my data if it's dirty? I promise you, I will go into each. We only did this one.
We're gonna be here all night.
My Fitbit is giving me a party when I'm trying to get the time.
7:47.
Yes, 7:47. It can be 7:47. What is it, 6:47? What time is it?
7:48.
Jeez, what time are we supposed to be done?
Stop answering questions.
No, I want you to learn, really, truly. Because at the end of the day, if you leave here and you do not understand this, and it's so critically important to you as a product manager, I have not done my
Can I
job.
help you with your computer a little?
You know, if you can come help figure out how to, I can do machine learning, but I can't figure out how to get this. I got limitations. All right, I don't know how to turn off the screensaver. Okay, yeah, and when you figure it out, let me know. Yes, question in the back. Yes.
The question is, does the adaptation change the quality of the data? And do you need to change the model to take the adaptation into account?
Okay, so
There you go.
never.
Thank you.
I saw that thing. And I had
You change it
no,
back afterwards, otherwise you're gonna screw up your battery. But
I had no idea. Actually, that is such a bad user interface. Such a bad user interface. Thank you. Thank you. Thank you. I was waiting on someone to do that. So maybe you'll do the interview with me later. Okay, I'm sorry, I got totally distracted. The question, in my limited understanding of remembering it, in other words, I forgot the question, is no, let me not make you work. So the question was, if I'm doing some adaptation, don't I need to feed that back into learning and the model? Maybe. Certain machine learning, you're feeding this right back into the model and improving the model, for sure. It depends. Again, it depends on your question and the target algorithms. Any other questions? Yeah? Okay. Jesus. Now, where does this fit into the product management lifecycle? This machine learning thing. Where does it fit? Okay. You have these 5 main phases or life cycle of the product. When you're doing the research and development, usually this is where you ideally would start thinking about where does machine learning fit? What are the questions? How can I incorporate machine learning into this product? And so you start learning here, collecting data. You start doing predicting as you're developing the product. Then you introduce the product into the marketplace. You're predicting at that point. But then as you grow the product, you may revisit the model, do some more learning, improve the model, do some more predicting, maturity. But then when it gets in decline, you probably don't care about the model so much because the product is going into life. So you see it changes depending on where you are in the life cycle. If you wait to a product introduction and you have not considered the role of machine learning, you're probably not going to have the best product that you can deliver. Okay, data. We are in data. Woo! Okay, so there was a lot of questions about data and labeling. So let's deal with that here. So data has different structure, has different scale, and it has different labeling. So structure, what type of data are you dealing with? Could be rows and columns that you're used to. This is called structured data. It could be long, meaning you have lots of rows, or it could be wide, meaning you have lots of columns. So for instance, this is an excerpt from the website design. I had 150 metrics or column, very long, but certainly not the longest. I mean, very wide, but not the widest. And I had thousands upon thousands, 5,000, 20,000 rows, right? Long, but not the longest. You could have bigger data sets. The other thing is it could be semi-structured, meaning an example is log files. Each log entry is like this. You have to parse it to separate out all the different things so that you can process it, right? To figure out, okay, this is a GET request and they're asking for this image, and then you have to do statistics on top of that because you got to turn all this into numerical data in some way. So you got to parse it. Or it could be unstructured, like blog posts. There's no structure there. So, or images. Well, images could be structured or unstructured, depending on how you use them. Films, videos, that's unstructured. You have no idea what's in there, right? Let me give you an example. If I had an image and I wanted to know, is the color red in this image? In that case, your image is structured data because an image is really a grid of numbers, pixels. Each pixel has a value, the color value, for instance. And then I could just scan this to look for pixels that have certain color values to say, yes, it has the color red. If I wanted to say, does this image have a dog in it? Now the image is unstructured data because it doesn't say there's a dog in this image. And even if the metadata said there's a dog in this image, I need to know, is there visually a dog? Now it's totally unstructured data. I have to learn through examples what a dog looks like, such that I can give it a brand new image and you can say, I see a dog in this image. Does that make sense? You look confused. Right here.
Okay.
No, right. Are you confused?
Oh, maybe I just look this way.
Okay.
I was thinking about photos and like computer vision, but then you talked earlier about natural language processing and text. So
Well, computer vision is an AI field too.
got it. So I guess.
And guess what? It uses machine learning.
Okay.
That's cool, isn't it? I'm just trying to get you to change your. No, I'm just kidding. Let me go on. By the way, I never have been very well behaved. Scale. People talk about big data, right? Are you dealing with big data? What does that mean? It means you have a huge volume. How big is it? Do you have terabytes? Do you have petabytes? Do you have exabytes? What are we dealing with here? And then velocity. How fast is it generating? If you're giving me terabytes every second, that's a lot of data. Wow, I can't handle that. That's scale. That's like Google search. They deal with like 7 billion queries a day. And they're generating these log files with tons of information about every aspect of the page and the interaction and all of that. That's big data. Variety. What different types is it? Am I just dealing with images? Am I dealing with rows and columns? Am I dealing with images and blog posts and all of that? This is what like Facebook and these social medias companies have to deal with. They're dealing with multimedia. They're dealing with the text you wrote. They're dealing with the images or whatever, the photos you put there. That's all big data. And then veracity. How accurate is it? Like when you deal with power plants and you get signals, sometimes it's messy. That's why they usually have data from multiple sensors, and then they fuse the result together or average them or get the median to say this is what the temperature is. It may have 3 to 5 different readings of the temperature from different sensors, and then it fuses that together to say this is what it is. But if your data is not very accurate, the veracity is questionable, that's probably big data too. And then the last is it beneficial? It should be beneficial to you, it should be beneficial to someone. Otherwise, why deal with it in the first place? If the data has no value, don't build a model around it. Okay, and then the last one is labeling. This was a question earlier. You can have labeled data, meaning you know what the answer is in your training set. You know, like in the case of the web design, I had all these rows and I had this rating associated with every page. That's an answer. Now what I'm trying to do is take this data and understand how to get to that answer. So it's labeled data. Or you can have unlabeled data. Like a film. You don't know what this is, but that's your input into the model. And so, depending on whether you have labeled or unlabeled data, all of this determines which algorithms you can use. And you need to know this up front, based on the question, because depending on your question, you might have to label data. Can you imagine having to manually label thousands upon thousands of rows of data? Okay, some of the things. So we talked about cleaning. Yeah, 10 minutes, sure. All right. All right. So how about this? I want to make sure we get through this. We probably won't get a chance for the interview question, which is the one you probably really want to do. But let's try to move through this. So when you clean it, the first thing you need to do is remove noise. You want to remove the bad data, like if you got missing values in a column or row, or it's just bad, strange numbers, just get rid of it. Then you might want to convert, maybe you sporadically have missing values for one reason or the other. You need to figure out what you're going to do with those. Are you going to convert it to some of the number? Sometimes when you have constants or categorical fields like true, false, or A, B, C, D, you need to convert it into a number because some algorithms do not allow you to put textual data in there. The other thing one of the mistakes that people make is using percentages or ratios of numbers when you're building models. 80% means nothing, right? So the better thing to do is to have the numerator and the denominator as a separate field. It'll learn the relationship between these that may go into prediction. Might have to do other filters. Normalization. Sometimes you have numbers that are too big, too small. Think bell curve. You want the data to have a certain shape. Some algorithms assume that your data is normalized. It follows a bell curve. And so you have to shape the data to get it there. You gotta maybe, replace the too small values with, the closest, smallest value. Or maybe your data has to be in z-scores. So instead of having, the number of bytes in a web page range from 0 to, 100,000, it ranges from 0 to 1. And all your columns range from 0 to 1. That's easier. Everything's on the same scale. So it's easier to build a model around that. And then there's feature extraction, where you want to go through and try to figure out which of these fields are actually helping me answer my question or generate predictions. If you have things that are providing no value, take them out. That means your model has to work harder and it's just extraneous data. So you remove the things that are not valuable. Combine fields, reduce fields. There's a lot of different algorithms you do. This is why the data prep phase takes so much time. Now, if you're using deep learning algorithms, you don't have to do the feature extraction because it learns the features as it's building the model. Here's an example of the data from this web design. This is just a subset of all the columns here. I randomly generated this data, but the point is you also have, the ratings and the orders. This is like an input into an algorithm, just an excerpt of what you put into algorithm. This is a structured data example. We're here. We just finished the data part. Now we're going to talk about the model building and evaluation. I'm not going to talk about this part too much. All right, so this came up as well, which is you have different algorithms. You have algorithms that are supervised, meaning you have labeled data. So if you know up front you're targeting a supervised learning algorithm, then you need to have labeled data. And then, like you said, you split your data into a training set and a testing set. Usually 70% goes for training, 30% for testing. Two major classes of algorithms. One is regression, when you're trying to predict a numerical value, right? And what it does is it looks at all your data points and tries to draw a line through them. Try to fit them to a line. Then you got classification. Like in my case, I knew which bucket the sites or pages were in. How do I build an algorithm that properly puts them in those buckets? And in the process, it learns what's important and the relationships among those different variables to be able to do this. Unsupervised, you don't have labeled data, so you use all the data for training or learning. But the other thing is, you understand how the models are working. Like regression is an equation. You can see the coefficients. It makes sense. I can say, oh, this one has a big coefficient. It's adding. This one is subtracting. Classification, same thing. You can reverse engineer. Like maybe this is a decision tree or other rules. You can reverse engineer and understand them. These, you have no idea how they got to this answer. Like clustering is figuring out based on the distance between the different data points, which group they belong in. You don't label the groups in advance, you figure it out. Then you have no idea why that data point is in that cluster. So you gotta go back and try to figure that out. What is it that distinguishes these clusters? Neural networks, now that's a whole other animal. You put inputs, each field is an input node. It goes through successive network of nodes where every node, it gets a signal. And then collectively, once it works through this network, you get some outputs on the other side. You have no idea why it got there. Same thing with deep learning. You have no idea. You can't reverse engineer. You can't look under the hood. And you have to be okay with not understanding how your model got to its answer. And just say, I just want the answer. I don't care how you got there. And then reinforcement was something that was talked about earlier. So these are things where they're constantly monitoring the environment, interpreting what it means. It has rewards for certain things. If I do X, my reward is this, maybe +1. If I do Y, my reward is -1. Based on that and the status detected from the environment, the agent decides what to do, what action to take. Think like the Go game. Think like autonomous vehicles. It's constant. The model is a live model, constantly taking inputs, taking action. Based on those actions, it adjusts the model. Yes?
Can you give an example of clustering and neural networking?
I will. But remember, we can't ask questions. So, I will show you an example because I used it in the web design. Okay, so a couple things to keep in mind about these algorithms. One is accuracy. You can build a model that's very accurate, but if it only predicts a little bit of variation in your data, that's not a complete model. Like, say it's 90% accurate, but it only explains 10% of the variation in your data. That's not helpful. That means you need to either go with other algorithms altogether, or you're going to have to create multiple models and fuse them together to answer this question. You need to understand how applicable the model is to new data. You don't want to overfit to the data. So there's ways that you try to do that through cross-validation, where you split the data into random, like 1/10, 10%, and you train on those to try not to overfit. Your algorithms usually don't tell you about causality. So you can't confuse, I got this result, it means X happened, right? All it can tell you about is correlations. So it's no, I did X, therefore this happened. There's no cause and effect. And then ethics. You probably hear about this a lot around machine learning, which is personal data, you're not projecting it, or privacy. Fairness to all populations, like if you have credit card algorithms that decide to accept or not accept people based on certain demographics, that's not fair, right? And then we've heard about fake news, and we just have to be careful about model behavior and use as well. Here's an example. For this one, what I used was an unsupervised method of clustering to figure out the 3 different buckets. And then what I used is supervised. I used regression to understand the clusters. And then I figured out which of these fields were actually predicting. And it turns out all 157 were predicting. So I then put them into classification, which rendered decision tree rules like this. If the italicized body word count is missing, or italicized body word count is less than 2.5, and minimum font size is not missing, and so it goes on and on. Some of these rules are really, really long. And so when I put new data in that has the same structure, it'll match up to one of these decision tree rules that'll tell me the class, like poor. So we had a tool that we used, and designers could run their sites through here to understand whether they're designed. And then we took these rules and then surfaced them in a way where they were more meaningful. Okay. So we're getting to the end of this. You choose whether or not to deploy these models. So let's just say you have a high accuracy on training data and low accuracy on test data. Would you deploy this model?
No.
No. Okay. The ability to guess people's social security number. Would you deploy that?
Depends on what you need.
No, depends on purposes.
I don't think you would ever do that. That's such a huge ethics thing. So it's a no. Do people do this? Probably. High accuracy on training and test data, and it explains less than 5% of the variation in data. Do you deploy?
No.
No. Right. Why?
Low value.
Low value. Unfair portrayals of people from certain backgrounds compared to those from people from other backgrounds. Do you deploy?
No.
Guess what? Image search has this problem. I worked on it, the policy. High accuracy on training and test data and explains over 40% of the variation in the data.
Yes.
Yeah, only one. It's 40%, it's not 100%. But that's meaningful. I can maybe do some other model to get higher, right? Okay, so we went through this process. Does this make more sense to you now?
Oh,
Yeah, we went in, right? Well, we went all in. I wanted to do this how much more time do I have?
Well, I think you do 5 more minutes.
5, okay.
5?
Do you want, okay, let me ask. Would you like for me to talk to you about landing the?
Yes.
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 We do.
Yeah.
So they want 5. All right, cool. So, look, it's a thing. I just did this search yesterday. Indeed, 400 posts. LinkedIn, 400 something. Simply Hire. There is a lot of jobs that are requiring machine learning, artificial intelligence. It's at big tech companies. It's in the mid and senior levels. It's on the east and west coast. It requires stronger tech background and more experience. And there's posts, they talk about data, big data, analytics. These are all code words you should be using in your resumes if you have this background, right?
Don't get it up.
What?
I'm sorry.
Don't what now?
I was like, please don't need it onto the photo. Thank you.
Okay, just eating into the 5 minutes.
Will we get a copy of these slides?
What now?
Will we get a copy of these slides? Are they posted somewhere?
They cannot be posted,
Oh, no.
but you can share through limited channels.
On the live stream.
It's on live stream, yes. So that's what I'm saying. It's on live stream. Remember, you can go back. All right. Here's an example job post from Google. But you see here, what are they talking about? The responsibilities is very similar to any PM responsibilities, but it gets interesting in the requirements, qualifications. Minimum, master's degree in computer science and an ML, AI, or related field, 5 years of machine learning experience working with research. Now, you can get this experience yourself. You don't have to, you don't have to go to school to get this. You could bootstrap this yourself, right? PhD in computer science. Whoa! Yeah, but here's the thing. Google, this is going to be, the number of people that can fill this role is like slim to none, right? Let's look at Amazon. By the way, Amazon has tons of roles like this, right? And they don't require all that nonsense. Bachelor degree, 4+ years of product management. None of their basic qualifications have anything to do with machine learning. Well, let's look at this. Okay, professional traits, knowledge of SQL database. Okay, guess what? You can do this on W3 schools. Sound business. Look, you don't even have to know machine learning. Imagine if you go in and talk about machine learning, how well that interview would go. So start where you are, get hands-on, get some data. At KD Nuggets, they have data sets. You can learn how to use a free GUI tool like Weka or RStudio. Learn some more via courses on KD Nuggets. Examine how it could be used. So start asking yourself, when you're thinking about products, how could it be used? Hardware, software products, how can we use machine learning? Practice. When you do interview questions and you're practicing, practice adding an ML angle to the questions, your response, right? You can do 3 to 5 side projects with real stakeholders. Guess what? Google may say they want all the requirements, but if you can come in with 3 to 5 interesting side projects to show that you've developed a skill and the likelihood of them filling it anyway is pretty low, you can do that. And then just expand your tech skills to be able to manage that. That's what I would recommend. So just to wrap up, we did distinguishing, here's a practice question I would have done. You can think about this, you take this home. But just assume you're the PM, you're doing an outfit recommendation app. You're the PM for the new app, it tracks user current, wardrobe, and accessories, captures a user's wardrobe and accessory purchases, provides weather, style, and occasion appropriate outfit recommendation. How would you go about applying machine learning to this product? So you can think about that. That'll be your homework. If you want to know if you have a good answer, you can reach out to me. And so just to wrap up, you've learned distinguishing machine learning from artificial intelligence deep learning? Yes? Did you learn how to distinguish?
Yeah.
Okay, good. You understand the ML process?
Yes.
Yeah, better than you did. You have some sense about landing a PM role? Yeah? Cool. All right, I've done my job. Google by day, NOS by night. I work with people to help them land roles, PM by nature. I'm on LinkedIn. You can check out, contact me on NOS too. All right, with that, I'm done.
To spend just a little time with Q&A, so I can take. We're running out of time, but I can take 5 questions if you want. If you still have time. You do.
They wore me out. No. Yes.
So just 5 questions.
Yes. Okay.
So you mentioned that you had used these algorithms on your website to determine what's a good design. Can you please talk about how you went about getting those algorithms and how did you use Google's infrastructure or did you use something open source and completely outside?
Mm-hmm.
So if I'm an independent developer, how do I leverage some of what you have used?
Okay. So keep in mind, I finished my PhD in 2001. That was a long time ago. That was before Google had their infrastructure. So what did I use? I used algorithms from SPSS, which is a statistics program. Today, what would I use? R, which is what I use now. R is free. You can even get a GUI front end for it, like through R Studio and R Command. And it has all these algorithms for free, right? So that's what I would use today. And your other question, so you're asking what did I use and what do you recommend to people to use? That's what I would use. And R you can do through the command line. It's like a list type environment, program environment. You can do a command line, you can batch things. I did a lot of batch stuff in SPSS because the reality is you don't know exactly what parameters every algorithm has different settings. And a lot of times you have to just trial and error over and over again, trying with different parameters, seeing the results. Now, I know for instance at GE, they were developing a tool that it would go and try to optimize your model, run it on all these different algorithms, see the results and make a recommendation. Without something like that, it's a manual process. Or you batch it. Yes.
So, what is the difference between the expectation and rules in the jobs that require PhD plus 20 years experience and the others that do not require PhD in computer science? And so the question is really, why is one asking for bare minimal technical experience and another is asking for the moon? Well, one is Google and one is Amazon. And remember who started these companies. One was started by PhD students at Stanford, and one was started by a business major from Wharton. I went to Wharton too, so I can relate to both of these entities. Yes?
Can you talk about, as a PM, products that were supposed to use machine learning that did not work and the reasons why?
I have not worked on a product that tried to use machine learning and didn't work. Because you have to, if it doesn't work, you're using the wrong algorithms. Or you got the wrong data. So you just keep trying. It's like, sometimes you have to do different manipulations or transformations to your data to get it to work. When you step into the hat of I'm building something, a machine learning, you don't stop until you build something that works. And you throw everything at it, right? That's how it works. Yes?
What's
stops people from deploying models that, that say they provide a prediction, but really it does not fit that 40% variance?
That wasn't the threshold, right?
Yeah.
You could have different thresholds. So if you know the model is crap, why would you deploy it? Or if you know it has ethical issues, why would you deploy it? As simple as that, right? If it's harmful to people or it's really not working well, because the minute your customers start using it, they realize that it's not working well, that's bad. All right. Yeah.
One last.
Yeah, one last. Yes.
Yes. So what are the opportunities to work in this field part-time?
That's an interesting question. Stumping question. What are the opportunities to work in this field part-time? Do you mean like less than a full-time job?
Yeah, like 20 to 30 hours a week. And let's say you have a master's in computer science, you graduate in artificial intelligence long time ago before it was cool.
Well, you just changed the name of it, right? See, like I did that when it wasn't cool. And then it became data mining. Yeah, I'm a data mining person. Then it became data science. Yeah, I'm a data scientist. Now I'm whatever is the flavor of the day, right? So there's a couple things. One is you could get experience and pay through competing. So for instance, Kaggle is a data mining, crowdsourced data mining, and you do competitions, and whoever builds the best models win prizes. And I think Google bought them. So there is a way to use that, to do that part-time, right? On your own time. You choose which things you want to compete in. If you win, you get money. But if you're saying, I want to get paid for these 20, 30 hours, consulting is a better opportunity. On Upwork, the fastest growing category is machine learning. People with machine learning expertise. So if you have that expertise, there's a lot of startups, a lot of major companies that are looking to bring on freelancers in machine learning. So that's another easy way to get into it.
All right.
All right.